Welcome to a primer on fundamentals of system engineering. It's a two-day technical management course on the basics of creating successful systems. Offered to you by ATI. I'm Bill Fournier. The course objectives are describe system engineering in an effective model, practice how to define, document, and manage system requirements, because requirements are the early part of driving what systems are to become. Practice how to create system configurations that can meet the established requirements. Describe how to ensure system quality during the development, and understand and practice the role of technical leadership. People who are working on any type of system development is part of the target audience, because system engineering is basically the modern way of how we develop systems. Project leaders are key members of the project development oversight team and looking for practical methods to use today. This shows the schedule of the two-day course, how we go from the model and requirements after an introduction. We have an exercise about an automobile throughout to practice it. We go from requirements then to solutions, and solutions we want to ensure their quality, and we show how the system engineering management and leadership affected, and then we summarize it. System engineering, as defined by NCOSE, which is the Professional Society for System Engineers, is an interdisciplinary approach and means to enable the realization of successful systems. It defines not only the need, the requirements, the functionality, documents those requirements, proceeds with design synthesis, or putting the design all together in an architecture, and system validation. It considers the complete problem, going all the way from the beginning of operations, cost, schedule, performance, training, support, test, disposal, manufacturing. It integrates all disciplines, all technical disciplines and specialty groups, and considers both business and technical needs. This view graph shows Eric Honor's doctoral research on showing the value of system engineering. It turns out around 14% of the system engineering effort of the project development program is system engineering. You'll have the best planned and actual delivery compared for cost and schedule. And what it shows is if you don't have enough system engineering, over on the left side of the slide, that you show both cost and schedule growth. And if you have too much system engineering, it also can create problems, because you have too many chiefs and not enough Indians to do the work. We also talk about a system engineering framework. The tools and methods, the terminology, the views, the life cycle model, the management policies and procedures and resources, the common technical processes for doing design, realization, and technical management. The workforce, which is part of this, is how we increase your competency and understanding of how to, if you're not a system engineer, how to better work with system engineers, and the capability. This is the model that we use throughout the course, and throughout the 2 days, we step down the life cycle of this model, starting off with operational definition, then requirements definition, into architecting, product design and implementation, the system integration and test, and all of those have feedback loops, which are the dark arrows here, and they all are influenced by the project technical leadership. And there's also various aspects of the system: operational, technical, architecture, design, and as built, and various design reviews that you might have in the life cycle, like mission concept review, system requirements review, system design review, final design review, and production readiness reviews.